Welcome back to Element 14 Presents. I'm Clem and look at this mess. I wish I could automate the cleanup. I better automate my lab equipment. I've got a serious new bench upgrade, including the most requested one by our viewers. And since sometimes it's useful to get the info directly blasted into your face, I'm this time a bit more direct with all the stuff. So all the equipment you've seen, as in the last video, has been purely selected by me and me only, which means I said what I wanted, and Multicomp was so kind to sponsor the equipment that I show you. But they had no say in what stuff to get or how I can talk about them and my verdict on these. So my opinion, their product. So thanks Multicomp Pro for sponsoring the video, but also thank you at home for demanding clarity and transparency. That's important. Thank you for that. Before we get to these cool new things, we should address the elephant trunk in the room. The community's nagging got me to upgrade the fume extraction system. Before, this is my DIY thing with just an exhaust that sucks in here and blows it out the vent through a filter. But they said, that's not a professional ventilation system and you need to have a professional system. So I got the biggest one with dual trunks, also made by Multicomp Pro, and this one has pre-filtering, HEPA filtering, and charcoal filtering, and I tied it into my existing exhaust system. So if I now press my remote, they both start at once. And you can hear them. They're pretty equal in loudness, but they do suck a lot of fumes away. I'm using both systems together. Turns out they both suck in a positive way. As long as you work closely to the inlets, they suck the fumes away quite nicely. But the Multicomp one, of course, has the edge because you don't have to adapt your building to your needs. You can just place this wherever you need, and you have the variability of these trunks. So, okay, Multicomp wins, you were right. I have another game-changing tiny upgrade, but I'll show you that later, okay? Let's talk about power. This benchtop PSU has now really proven its worth to me. It's very simple to use. I have presets on these. It's dual channel. It's super fast to set up and get going. This is a really good value for the money. But I can't program it. So I can't do any advanced measurements with it. I can only use this to power things, which is good. But it's not I want to have an upgrade. I want that to be better. So, introducing the Multicomp Pro MP711001. That's a mouthful of a name. This one is a bit more professional. I love the old power supply for its simplicity, but I like this for its capability. This has 4 channels. 2 of them are 0 to 30 volts at 5 amps, so quite a lot of oomph in there. There's a 3rd channel from 0 to 6 volts at 3 amps. This is for more precision power supply needs. And there's a 4th channel, which is a USB port. This is not the USB port for data storage. That's on the back with this unit. This one is to power USB devices, and we can restrict limits like in current and voltage and whatever, specifically for USB devices. But it's also programmable. All the devices that I have in this area of my benchtop are connectable via USB, Ethernet, and RS-232. Yes, that's still relevant. So the benchtop digital multimeter, the power supply, and a DC load. We speak about that later. Because I read all the comments, I know that some of you have pointed out that some of the devices that I've shown in the last video can also be obtained from other brands. And that is because Multicomp Pro is, of course, a house brand. And with house brands, I have some insider knowledge that I'd like to share so you understand what this actually means. So, house brands select devices they find on the market and add them to their portfolio, which means they curate whatever they find there, which is best bang for the buck, really great performance for the price, and can be had with some customizations, for example. So what Multicom Pro does is they find really good value devices, put them into their range, maybe they adapt them in some way, change the specs, add some software, maybe add some accessories, and they equip them with a longer warranty and better customer service. So what you get is the same thing, but from a trusted source where you can rely on getting replacements, getting your customer service, and also having to deal with one source instead of multiple dodgy vendors that you might find scoured around the internet. I myself did some curation and some testing for unrelated house brands, so I know what goes inside, and usually these are tested and put through their paces before they are added to the range, so you can be sure that only the ones that are really a big bang for buck get added to the Multicom Pro range. This is how it works. This is why I would prefer, if I don't have to go for the big ticket special name brand items for special purposes and have a cheaper option available, then I would always go for a house brand first. Then getting the same item from possibly a dodgy source or having to deal with a difficult return or warranty process. So you're getting the best one with some additional perks. By possibly not a coincidence, the power supply perfectly fits underneath my digital multimeter that I showed you in the last Workbench episode. I of course combine these as they are both programmable, so I can have a reliable voltage and current measurement over this precision instrument and don't have to rely on the output that the power supply tells me it does. These precision power supplies, they are usually fairly accurate, but not as accurate, of course, as a specified measurement tools. So I could even use these to calibrate against each other and to make sure that I exactly know what power is currently drawn and what voltage is supplied to a much higher degree than the device itself could. Just supplying power is of course not enough for a real testing scenario. I also have to have a load. So this is my upgrade from just precision resistors, basically. High wattage, low value resistors. These were precision resistors, but the only thing they can do is have a constant current draw. So that's all they do, and I can just exchange resistors. With a programmable load, I'm not fixed to any values, and I can do more than just simulate a resistive load. This one, the MP710771 programmable DC load, this one can do a lot. In any DC load, you usually get constant current and constant voltage. This also has constant wattage, so the total power consumption, not depending on how much voltage, how much current, it's the total, or constant resistance. And these modes don't end with constant ones, they are also dynamic ones. So each of these has a dynamic counterpart, dynamic voltage, dynamic current, and so on. And with that, you can program scenarios inside your load directly and have testing procedures that include even additional sense wires to make sure that the power supply will deliver whatever is requested. But there are also battery testing scenarios directly built in. But that would require for me to learn the interface of all these devices to use them properly. And I'm not good at that. I tend to forget which buttons do what, and the interfaces are not the same for each of the devices. So I'd better use them programmatically over the network and have them do my bidding just via some code. Let's get back to that a bit later. The trifecta of digital multimeter, programmable power supply, and a programmable load gives you a lot of measurement capabilities. You can even simulate devices you don't even have. If you want to test a motor driver and know if it would work with a bigger motor, and not a resistive load, but an inductive one, you can actually simulate that with your DC load. You can simulate draining batteries with your programmable power supply. And in total, I could have simulated how my robot that I built in another episode based on a Raspberry Pi 5 and was powered with lead acid batteries would have performed with a different type of batteries or with different motors attached. So I don't have to guess anymore how my things will perform. I can already know before I even buy the parts. I promised a tiny upgrade that makes a lot of difference. Last time I was hesitant about buying a lot of cables, so I just got one. And now I got the whole set, and not just like various banana plugs, but every combination of banana plug and a different thing like this hook and crocodile clamps and whatever is also on here. 3D printed some holders, and I now have all the cables I could ever wish for ready at my disposal. But that's not the significant tiny upgrade that I wanted to show you. It's this thing here. Last time I showed you this multimeter with a current clamp. Very handy thing, especially if you're debugging machinery in the field. But this only works on AC power. What if I want to have non-invasive current measurement for DC? I usually have to break up the circuit, but there's a new thing in town. Behold, the multi-comp current clamp for AC and DC voltage. This one takes a battery because it's an active probe, and I can connect this to a multimeter or an oscilloscope. So how does this one work? Well, you can just loop a wire through here, one of the conductors of your desired power, so only the plus or only the negative one, doesn't really matter. But you can now select the division of 10 millivolts per amps and 100 millivolts per amps for the output. That means if I connect this now to a multimeter, then for each amp that flows through the conductor, I would get 10 millivolts of reading on my multimeter. And I don't have to do a calculation via Ohm's law. I can just convert this directly to amps. So if I read 25 millivolts, that would mean at the setting of 10 millivolts per amp, 2.5 amps. And if I would have set it to 100 millivolts, then this would mean there are 0.25 amps going through the conductor at this very point in time. Which means I can adapt this to the scale of current I'm dealing with. And I don't have to break up the circuit anymore. It's less precise than the classic style of measuring, but good enough for all the purposes where I don't want to break out the power profiler kit or have a real precise measurement in the classic way. Yeah, still a bad idea. Welcome to the code void. Don't run away, because this time I'm not going through all the code in detail. I'm just telling you I made Python libraries for all of these devices that you have seen now. So you can control them not via the software that comes with them, which, okay, nice software, but I want to use them my way and the way I control them. And I would rather have one unified user interface one day, but of course I have to first be able to interact with the devices. So I made Python libraries, as hard to do as I thought. There were some quirks with some of the devices, especially the load gave me a difficult time. It uses an older procedure to obtain the measurements and whatever, but the multimeter was very easy to work with, and the power supply only had some little quirks to figure out how to set the other channels than channel 1. But now all these drivers work, and I have wrapped them together in a lab API. So based on this API, I've made a demo example that can show you how you can directly use these 3 devices, just connect them via cables, of course the power supply and the load in series, and the DMM in parallel, and now we can use them to calibrate them against each other and do a demo measurement that shows the accuracy of the power supply and the load. I've connected all my devices via Ethernet. That means any computer within the network can access them if they want to and use them programmatically. So I've used a Raspberry Pi on my Workbench directly with the screen you have seen next to it, so I can use all these devices without having to learn the interface. I can just do it with whatever interface I come up with later or use pre-programmed testing scenarios. But I can also use any other computer on the network, which means for sensitive measurements, I can even leave the room and run them from outside and still look at all the data in real time. You may want to do that if your setup is temperature sensitive or even air currents from you moving around the room could change the measurements. Or if you just want to set it and forget it, lock it into a room so nobody else messes it up. So now in our demo, we can directly determine how accurate is actually the voltage that the power supply reports that it's putting out. Is that really what it actually is putting out, or is there some variance? And turns out, thanks to the automated testing scenario, I now know at different voltages even and different power draws, there is a difference, but it's in the later digits. So for practical purposes, the output that my power supply reports is pretty much spot on, but for very precision measurements, yes, I would then use the DMM's output to know which voltage was actually applied or which came to the load, because I can even measure the voltage drop over the cables and take those into account with this setup. And of course the load and the power supply can perform different at different voltages and current levels. I can also automate that and just go through all the possible scenarios and then see how much the error in measurement is. And with that, I can pretty much build a testing setup that allows me to automatically test again and again, repeatably, but also I can simulate devices that I do not even have, like a bigger battery, a different motor, other loads that I want to power that I don't even have in my arsenal. So if, for example, I have constructed a DIY motor driver, I could now simulate different types of batteries it could run off and also different types of motors that I don't even have. If I want to know if I can power that huge motor I've seen on the web, now I know before I purchase it. Oh, and if we combine this with the arbitrary waveform generator from last episode, I've also started a Python library on that, but it's a bit more tricky. And then we use the newfangled current clamp with an oscilloscope. We even can see how much of ripple that we could inject into a power path would at the end get filtered out or just pass through a device and could still be influencing how the load performs. So I could even know the performance of any filter that I construct directly with this setup at various frequencies, various voltages, various current draws. Okay, that's quite a lot of capability that we just added with a few simple upgrades and a bit of code. Of course, you can download all the code for free and of course the equipment list for all the stuff that I used on the show. And please take a look at all the libraries that I made for these devices, because these might serve as an inspiration for your own libraries for more devices that you use in your workshop. I gotta go, and I let future Clem deal with this mess, because I've got another project waiting for me.